Good morning students. Today we are going to see Unit 1 Laws of Motion from page number 5 to 8 in your science book. Objectives: to prove the statement of principle of moments, apply Newton's concept of force and motion, analyze the principle of conservation of momentum. Now let us recall the previous class portions. Moment of force. What is the meaning of moment of force? The moment of a force is a measure of its ability to cause rotation. The rotating or turning effect of a force about a fixed point or fixed axis is called moment of the force. It is measured by the product of force and the perpendicular distance. The SI unit of moment of force is equal to Newton meter. Direction of moment of force is taken as positive in the anti-clockwise direction. The direction of moment of force is taken as negative in the clockwise direction. Now, let us begin today's portion, principle of moments. Principle of moment states that anti-clockwise moment is equal to clockwise moment. Example, moments acting on a seesaw. Both people A and B exert a downward force on the seesaw due to their weights. Person A's weight is trying to turn the seesaw anti-clockwise, while person B's weight is trying to turn the seesaw clockwise. Here, seesaw is in equilibrium. If the object is in equilibrium, then the total sum of the anti-clockwise moment is equal to the total sum of the clockwise moment. Now, what is equilibrium? When a system is stable or balanced, it is said to be in equilibrium, as all the forces acting on the system cancel each other. From the above explanation, let us see the statement for principle of moments. When a number of like or unlike parallel forces act on a rigid body and the body is in equilibrium, then the algebraic sum of the moments in the clockwise direction is equal to the algebraic sum of the moments in the anti-clockwise direction. Now, let us prove this statement. In a figure, the force F1 produces anti-clockwise rotation at a distance d1 and force F2 produces clockwise rotation at a distance d2. By principle of moments, moment in clockwise direction is equal to moment in anti-clockwise direction. You know that the moment of force is equal to F into d. Here, two forces are acting on a body, then F into d1 is equal to F into d2. Let us take F1 is equal to 20 gram, d1 is equal to 0.2 centimeter. Then F1 d1 is equal to 20 into 0.2 is equal to 4 gram centimeter. F2 is equal to 10 gram, d2 is equal to 0.4 centimeter. F2 into d2 is equal to 4 gram centimeter. From this, you know that moment in clockwise direction is equal to moment in anti-clockwise direction. Now, next topic, Newton's second law of motion. Newton's second law gives the cause and effect relationship between force and changes in motion. If you use the same force to push a truck and push a car, the car will have more acceleration than the truck because the car has less mass. As a result, when the force acting on a body is increased, the acceleration increases. Likewise, the mass of the body is increased, the acceleration decreases. From this, the acceleration is directly proportional to force and inversely proportional to mass. According to Newton's second law, the force acting on a body is directly proportional to the rate of change of linear momentum of the body, and the change in momentum takes place in the direction of the force. This law is also called as law of force. Now, let us see how to derive the equation of a force by using Newton's second law. Let us consider the mass of a moving body m moving along a straight line with an initial speed u. When an external unbalanced force F is applied on an object after a time interval t, the velocity of the body changes to v. Initial momentum of the body Pi is equal to mu. Here, P represents momentum, that is, momentum is equal to mass into velocity. So, Pi is equal to mu. Final momentum of the body Pf is equal to mv. Change in momentum is equal to final momentum minus initial momentum is equal to Pf minus Pi is equal to mv minus mu. By Newton's second law of motion, force F is proportional to rate of change of momentum. F proportional to change in momentum by time. Change in momentum is equal to mv minus mu. So, F is proportional to mv minus mu by t. Here m is common, so let us take it out. Then F is proportional to mv minus u by t. Now, remove the proportional sign. Now, F is equal to kmv minus u by t. Here k is the proportionality constant. When you substitute k is equal to 1, then F is equal to mv minus u by t. You already know that acceleration is equal to change in velocity by time, that is a is equal to v minus u by t. So, instead of v minus u by t, you can substitute a. Hence, the equation F is equal to mv minus u by t becomes F is equal to ma. If the motion of a body moving with uniform velocity, then no external force is needed. If the net force is not equal to 0, then definitely the velocity of the body will change. So, the change in momentum takes place in the direction of force. Force is required to produce the acceleration of a body in a uniform circular motion. The speed remains constant. If the speed remains constant, the direction of the velocity changes at every point on the circular path. So, the acceleration is produced along the radius called as centripetal acceleration. The force which produces this acceleration is called as centripetal force. Now, let us see the definitions. Unit of force. SI unit of force is Newton, and in CGS system its unit is dyne. Definition of 1 Newton. The amount of force required for a body of mass 1 kg produces an acceleration of 1 ms minus 2. That is 1 Newton is equal to 1 kg ms minus 2. Definition of 1 dyne. The amount of force required for a body of mass 1 gram produces an acceleration of 1 centimeter s minus 2. 1 dyne is equal to 1 gram centimeter s minus 2. Also, 1 Newton is equal to 10 power 5 dyne. Unit force. The amount of force required to produce an acceleration of 1 ms minus 2 in a body of mass 1 kg is called unit force. Gravitational unit of force. In the SI system of unit, gravitational unit of force is kilogram force. It is represented by kgf. In the CGS system, its unit is gram force. It is represented by gf. Now, the value 1 kgf is equal to 1 kg into 9.8 ms minus 2 is equal to 9.8 Newton. 1 gf is equal to 1 gram into 980 centimeter s minus 2 is equal to 980 dyne.